So question 7 says, how many years will it take for an initial investment of $40,000 to grow to $60,000? Assume a rate of interest of 18% compound continuously. Now, this is more like what people are dealing with is bigger money, the $40,000 and $60,000, investments. If you're going to try to retire, you're going to have a lot of money in the account to retire. So we're now starting to get up there in those types of numbers. So again, notice that compound continuously, we have this formula A equals P to the RT. So if we look at this problem right here, we have A, do we know that? How many years will it take an initial investment to grow $60,000? Remember, A is the future value or the final amount, which is the 60,000. The P is the initial amount, which was the initial investment was 40,000. So we know how much time it takes to do that. Some other things we didn't know is the rate, which was 18%. Again, notice how it said compounded continuously. That's how I need to use this E formula. But we don't know the time. That's what we're looking for. So again, since the unknown is T, I want to write the PERT on the left side. So P times E to the RT is equal to A. So the 40,000 would be the initial investment. E, we have our interest rate of 0.18 times the time. And that's going to equal then this 60,000. So if we want to solve this for T, again, we have to have same bases. We don't. So that's where the property of equality comes in, and we can actually take the natural log of both sides. But before I do that, though, I really want this 40,000 to go away. It's going to be a little bit easier to deal with if that's out of the way. So we want to divide first to get this 40,000 out of the way. So that's going to drop out. That's going to just leave me the E to the 0.18T. That looks a little bit cleaner there. So notice all these zeros are going to drop down. So you're going to have like the 6/4. So what is 6 divided by 4? So 1.5. Again, if you wanted to, you could type 60,000 in. And you can divide it by 40,000. And you still get that 1.5. But notice how all the zeros actually divide out because each zero represents a factor of 10. And 10 divided by 10 just drops out. So each zero really means a 10 there, since we're talking place value. So yeah, I can now get this T focused on by taking the natural log of both sides. So by doing that, the Proctor logarithm says I can actually bring the 0.18T out in front. And I have the natural log of E equals the natural log of 1.5. As I said, though, the natural log of E actually is 1. That's a property of logarithms. So we just have really 0.18T is equal to the natural log of 1.5. So to find the time, just divide both sides by 0.18. So all we really need to do is use the natural log button. So the natural log of 1.5, close parenthesis, and then divide that by 0.18, and that'll give my amount of time. So 2.25 years. So say this is, yeah, it says around to 2 decimal places. So in 2.25 years, your account moved from 40,000 to 60,000. So notice that's a big chunk of change. So notice that interest rate of 18% allowed me to make $20,000 in 2 years without doing anything. So that's the power of money growing money. I like that. $20,000 in 2 years. That's $10,000 a year that I made. It's pretty good. So I hope you find that useful.